Okay, here we go with a standing sound wave. We've got an open tube, and we know that the standing wave has 2 nodes. What's the wavelength of the standing wave? Okay, hopefully you've had a chance to have a look at that one, and you've given it a go. When I think about these, I always, in my head, start to draw the wave. So I've put these up just now, okay, and let's think about which one we're looking at. Okay, the standing wave in an open tube, the basic idea here is that we have an antinode and an antinode forming at each end. So these are the images that you should have in your brain. Now, the standing wave in this case has 2 nodes, so I'm looking here, I've got antinode, node, antinode, antinode, node, node, antinode. So this is the one that we're looking at here. We're looking at the n equal to 2. Now, hopefully you can see, if I just trace this wave, I've got a peak, a trough, back to a peak again, which means that this length is equal to the wavelength of the wave in there. In other words, our answer here is C. Okay, now you can hopefully see that as we're going up in order, our wavelength is decreasing. So in this case, our wavelength is equal to 2 times L. We've got then L here. This would be a bit harder. How many waves we've got here? We've got 1.5 waves, so therefore our wavelength would be 2/3 of L, etc. Okay, so we're decreasing wavelength. In this case, nice clean answer is just equal to L.